There are several availability characteristics that should be taken into consideration when determining CF configuration requirements. Non-volatile, battery backup, and/or uninterruptible power supply. You identify the CF is attached to a UPS via CF command. Failure isolation. If a disruptive microcode chain is required by the CF, operating systems will be unaffected if the CF is in a standalone CF. If a disruptive microcode or configuration chain is required by the operating system, the CF will be unaffected if the CF is in a standalone CF. Structures may be duplexed across different CFs, allowing two copies of the same structures to be kept synchronized. Duplexing is used to remove single points of failure. In the event of the failure of one CF, the other copy of the structures is used to satisfy all requests. CF duplexing can be user or system managed. Failure independence describes the need to isolate the CFL part from exploiting ZOS images in order to avoid a single point of failure. This means that the CF and ZOS image should not reside on the same CPC. So, for some exploiters, GRS, RACF, JES, VTAN and others, CF failure independence is not required. On the contrary, exploiters such as IMS, DB2 and others usually require CF failure independence. Failure independence is an attribute which is applicable to each instance connected to a structure. It is determined by the location of the instance connected to a structure and the location of the structure. Simply stated, failure independence occurs when the instance connected to the structure and the structure do not reside in the same server. Failure independence is a term used to describe the situation where a double failure recovery scenario will not occur. It is important to remember that failure independence may differ for every connected instance. It is not a global attribute of the structure, nor necessarily for all instances connected to a structure. The terms failure independence and failure isolated are used interchangeably. Failure independence is required if concurrent failure of the CF and one or more exploiting operating system images prevents the CF structure's contents from being recovered at all or causes a lengthy outage due to recovery from logs. When the same server is used for both ZOS images and CF images, failure independence requirements should be followed. Will the loss of a CF and operating system at the same time cause an extended recovery time or Sysplex outage? If no, the CF and Sysplex member may reside on the same physical CPC. If yes, the CF and Sysplex members may reside on same or separate physical CPC if CF duplexing is properly exploited. If yes and not CF duplexing, structures that require failure isolation should be on separate physical CPCs. If failure independence requirement is no, the Sysplex environment on the left is valid, and it would be valid also if independence requirement is yes, but CF duplexing is enabled. The Sysplex environment shown on the right is valid if independence requirement is yes. Structures that require failure isolation should be located on a standalone CF. Coping facility structures rebuild is a user-managed process that allows structure connectors to allocate another coping facility structure with the same structure name. The structure connector can then reconstruct data into the newly allocated structure. Coping facility structure connectors can change the location or attributes of the structure during rebuild without having to disconnect from the structure. Structure rebuild is intended for planned reconfiguration and recovery scenarios. Installations might initiate structure rebuild because of loss of connectivity to a coupling facility or a structure failure. Structure rebuild can be initiated by an authorized program, by an operator, or by ZOS. The macro and the setxcf start rebuild command are used to initiate the structure rebuild. The process of rebuilding a structure is complex because the structure exploiter is responsible for managing its own rebuild processes. When a rebuild is system managed rather than user managed, the system performs all of the significant steps in the overall rebuild process on behalf of the connectors to a structure. Only minimal participation by the connectors is required. System Managed Rebuild supports planned structure rebuilds only. Recovery situations still require the use of user-managed rebuilds. User-managed rebuild is intended for planned reconfiguration and recovery situations. The installation might initiate the rebuild process because of loss of connectivity to a coping facility or a structure failure. The user-managed rebuild process requires the structure connectors develop protocols among themselves to control the rebuilding process. The system reports certain rebuilding events to the event exits so that the structure connectors can coordinate the rebuild processing. The major events that the connectors must coordinate include keying access to the structure, allocating a new structure, connecting to the new structure, and then repopulating the data in the new structure if necessary. Some exploiters, such as Jest2, have chosen not to support user-managed structure rebuild due to the complexity of the rebuild process. Jest2 relies on its existing recovery mechanism, checkpoint reconfiguration, rather than using the user-managed structure rebuild. System-managed rebuild can successfully rebuild a structure even when there are no active connectors to a structure. System-managed rebuild is intended to be used to support planned coping facility reconfiguration. Therefore, it does not rebuild the structure onto the same coping facility. System-managed rebuild was an effort to simplify the rebuild protocol. Simplification of a structure rebuild should make it easier for exploiters to support structure rebuild. Jest2 is an example of an application that chose not to support rebuild in the past. However, it was being changed to support system-managed rebuild. System-managed provides a means for rebuilding a structure with a minimal participation of the structure connectors. During the rebuild process, the system manages accesses to the structure, the old and new instances of the structure that exist during rebuild processing, and the propagation of data into the new structure. System-managed rebuild is intended for use in planned reconfiguration scenarios only. The system allocates the new structure, populates the data into the new structure, and then switches over the use in the new instance. System management rebuild can only function as long as the old and new structures remain ready and there is at last one system in the Sysplex capable of performing the required system managed processing.